Now we're going to talk about VVNA, or verification, validation, and accreditation. This, of all the things that we do in defense modeling and simulation, this is one of those things. This would be on a relatively short list of topics that are somewhat unique to our discipline, meaning that without good practices for VVNA, how do you even know what we're doing or what you can use our products for? So this is an extremely important thing to do. It can sometimes feel like a little bit of a black hole, so you want to be very careful. You want to understand it the best you can and realize that you're making trade-offs through this entire thing. But just understand what you're doing and be able to communicate it is the best advice I could give. Now, verification, the first V, is essentially it's almost like a software engineering step. It's just determining that the thing you built is what you said you were going to build. So you specified a piece of software, some programmers built a piece of software. Is the thing they built the thing you said you wanted to build? So did you build it right is the question here. Validation is the trickier one. It's the one that I think that you would probably assume is what we're talking about most of the time is, okay, let's assume you passed the first V, you built the thing you said you were going to build, so what? Does that really represent the real world? Can you use it for anything? I could write perfect code according to a specification, but the specification's no good. I can't use the model. So the second V is the real meat and potatoes of VVNA, in my view. And lastly is accreditation, which is just a specifying step of, or certifying step of, okay, you did the first two V's, now we know what's the purpose that this thing is for. We know that it's useful for this set of tasks. The idea here being that if we all follow the proper VVNA practices, the clearinghouses for modeling and simulations, that would be all of the MSOs, AMSO, NIMSO, MCMISMO, what used to be DIMSO, now the Modeling and Simulation Coordination Office, MISCO, would all have shelves full of these models that you could go and say, hey, I need an M1A1 model for this particular purpose here. That one's pretty good. And you just go grab it off because you could read its accreditation documentation, know exactly what the purpose was that was built for, what did they use it for. If it's close to what you're doing, you could use it. We're going to look at later, that's what we're going to call a legacy model. It does happen, not often enough though. I love this slide because it's kind of brutally honest that the balancing act in VVNA is simply the balancing of the cost of knowing against the risk of assuming. So given enough money, I can just keep pouring resources into a model. So, in other words, the cost of knowing could be infinite. I could just keep pouring money into this thing and making sure that it's exactly what I said I wanted. We don't have that kind of money. So you're going to build a model and you're going to put some effort into knowing what it can do. And there's always going to be some vagueness, which is the risk of assuming. You're going to balance those things the best you can. Because what the worst thing you want to do is be able to produce a model that gets used in some simulation and you really don't know what it's telling you. That's too much risk. But the fact that there's some fuzziness in what the answer is, you know, anybody who takes a modeling and simulation product and assumes that it is a faithful representation of the real world in every possible way, that must mean that we're not communicating things very well, because they never are. I'm not going to talk too much on this slide because we're going to look at it in a little bit larger form here a little bit later, but this is an important picture. You will see this picture, this exact picture repeated in a lot of documentation on VVNA and the different services. Some main things you want to keep in mind are, look at the blue, the green, and the purple box right in the middle of the picture. The top one is preparing for legacy M&S, the middle one is new M&S, the bottom one is federation. We're going to look at all three of those here in a moment. But in each case, there are a number of steps very similar to what we've talked about in terms of software development. The planning, the conceptual models, the designing and prototyping, the building, and then there's VVNA steps all along the way that mirror those, that make sure that as you're specifying, you're doing some of the V and V part while you're doing specifying, while you're doing prototyping, so you have a pretty good idea of what it is you have by the time you get to the end. Now, some high-level guidance on just the basic VV&A problem is maintain your problem orientation. So you're building a model, or you're working on a model, retrofitting a model or something for some purpose. Understand what the problem is that you're trying to solve. How is M&S going to help you? What is the VV&A? What is the role of VV&A in what you're trying to accomplish here? If it's too complex, tear it into parts. We learned that too when we talked about big software. Complexity is not your friend. If something feels too complex, it probably is. Decompose it. Figure out how to decompose the problem. And you want to focus on that accreditation, because that's the end. That is the end state. That's what you're shooting for. And when you're trying to understand your problem, you want to explicitly define what the requirements actually are. Now, does this sound familiar? This is exactly what you ought to do in any software problem, not just an M&S problem. This could apply to real-time simulation software as well that you may not be applying VV&A to. You're still going to do this. What are the questions that are going to be answered? What are the measures of effectiveness that are going to be applied? How is M&S going to be used? What does it need to do? How good does it need to be? These are all questions that you should be able to answer up front, probably by talking to your customer. You want to define what questions need to be answered. Define what the M&S needs really are. You don't go beyond that. Don't try and put more in it than needs to be in it, because then again you're adding complexity and making your problem worse. And you want to define the acceptability criteria up front. You don't want to do that after the fact, or leave that for somebody else to make up when you're done. You want that up front. And of course, an explicit statement here of what the choices are, and this is the most important aspect of cost-effective VV&A, and it's going to be the hardest thing to come by. So you're going to get involved in building models and simulations that you're going to go through the VV&A process. Do your legwork up front. Don't allow anybody to push the VV&A to be some tag-along thing at the end of the process. You will not be happy if that happens. Now, this is a real important part of this, because VV&A is a lot about credibility, and credibility is in the eye of the beholder, or the customer in this case. It has a cost, so you got to make sure you're talking to the right people. You want to set that level of credibility as low as you can for the intended purpose. There's no point in going beyond it. You have a specific reason you're doing this. Meet the criterion for that purpose and don't go past it. You want to know, when you talk about the credibility of your model, you want to know what the limits and tolerances are. So what happens if you get a bad answer? How bad is that? Is that just going to be, could be that you're going to put your model through some sort of a Monte Carlo simulation, and it's going to crank out a bad answer once in a while, but in the statistical model you're going to apply, it's not going to mean anything. On the other hand, it may be the opposite extreme, where you're going to run it once or twice, and if it gets a bad answer, somebody's going to make a bad decision. You need to know the difference between those things. So you want to tailor your risk analysis to the level of credibility requirement. So how much risk you can tolerate it is going to define how much credibility you require. If you can tolerate some risk, that is, you can stand a bad answer now and then, you can lower your credibility requirements. You can get this thing done quicker, and you can sort of have a wider window, if you will, to go through. But if you can't tolerate any risk, you really better put some effort into making sure that your credibility is where it needs to be. Now you want to talk about how to optimize your resources in the V&V process. The main thing here is you don't want to do anything yourself that's already been done, even somewhat, by somebody else. We've been talking a lot in this course about the importance of reuse, and the fact that we don't do enough of it in M&S. VV&A is just another example of exactly what we've been talking about. You want reuse. We're going to talk about legacy systems in a minute, and I wish they all were legacy systems, or nearly all, because that would mean that we're grabbing models off the shelf and repurposing them for new uses, reworking the code, changing the data, whatever it is we need to make it what we need for a new purpose, and we'd be saving money that way. Unfortunately, that doesn't really happen all that often. Another thing you want to do, we're going to talk about documentation at the end, is there are examples of all this stuff online. I'm going to give you a website at MISCO in a few slides, and everything you need is there. All the documents are there. All the forms are there for every type of model you're going to want to do. Example procedures are there. You really don't have to do a whole lot of thinking. There's not a lot of excuses for not doing VV&A anymore. So some problems that you might run into in your V&V implementation is the lack of a well-defined referent, that is something to compare it to. If you can't compare it, that second V is going to be pretty tough to figure out how you validate a model when you don't have anything to compare it to. So that can be a problem. In my opinion, we use subject matter experts a little too often in our V&V process. We tend to grab a bunch of people who really ought to know about this domain, show them our model, tell them what we think we're going to use it for, and they give you the head nod, yeah, that seems good, and we call that validation. That's pretty sketchy in my view, especially because most of our subject matter experts are not M&S people. They don't really understand how you're going to use this thing or what sorts of decisions are going to be made. I'd like to have something a little bit more solid than that in how to do my validation, but at least know, if you're going to use subject matter experts, how you're going to use them and where you're going to use them. In some cases, there's a lack of insight into the modeling and simulation. That is, the source code, where the data came from, et cetera, et cetera. There's a lack of stability, so things are changing underneath you. That can be a problem. You may, like I was saying before, you may start the VV&A process way too late. This happens all the time. Nobody even thinks about it until project's almost over. We're about ready to ship the model, and somebody says, hey, we need to do VV&A, and they very quickly slap something on the back end, and it's always a mess. And then keeping the second V in V&V. That's the hard V. The easy one is making sure that you wrote the source code right. The hard one's making sure that the thing you built has any basis in reality. We're going to spend a few slides talking about these three different categories, and they were on that schematic that I showed earlier. There's new M&S. That's new. It's just we're going to start from scratch. We've got a new requirement. We're going to build from scratch. Legacy. I hate that they use the word legacy, because when we use the word legacy when we talked about software and system architecture, it was kind of a negative thing. It means it's old and we'd really like to get off of it. In this case, legacy is actually a good thing. It's reuse. It's a model or simulation that was developed for something else, and we're going to repurpose it. In my view, that is a good thing. We should be doing more of it. And the last thing is a federation, which is not so much the actual model itself. It's the collection of models that would be used in sort of a constructive simulation or something like that. We're going to see a lot more of this in the future, because as we start to do more VV&A at the module level, we've talked a lot in this course about how to cut software in, a big software into little software. When we start thinking about VV&A at the module level, then how you snap these different pieces together is going to impact VV&A. So I could have a quote-unquote model built up of 4 or 5 modules or components that I run through a good VV&A process, and it passes, and I document, and I do all the things that I'm supposed to do. Now, what happens if I pull one of those modules or those components out and replace it with a different one? Because for a good reason, that it needs to be changed for my new purpose. Well, I got to go through VV&A again, but should I have to go through VV&A all of it, or should I have some sort of a streamlined version? I don't know the answer to that, but that's where it starts to look like a legacy system a little bit. So we already mentioned this, so I won't talk about it in great detail, but here's the same picture you saw before, and if you look in the middle, you've got developing new M&S, you've got refine your requirement, plan your development, develop conceptual model, develop your design, implement and test. And look what's right underneath it is the VV&A mirrors of all those components as you go through. So if you're doing this right, your VV&A is taking shape while your code is taking shape. So at the end of this thing, it all comes together at one time, because you've got feedback loops. You're able to determine V&V problems before you get to the end, which can feed back into your software development, and you can get them fixed before you ever get to the finish line, which is really when you want to get it done anyway. This flowchart really talks about these legacy M&S, and really what you're looking at here is sort of a decision tree of how you go through selecting legacy models and thinking about how you can modify them. So the first thing you're going to ask is there sufficient information to assess it? If there isn't, don't use it. Go do something different. If there is, what do you know about it? Do you have access to the code? Can you modify the code? Are you allowed to modify the code, or is it proprietary or licensed in some way? These are all the questions that have to come up when you're dealing with legacy M&S. But again, if we're smart buyers in the way we develop models and simulations for the Department of Defense, such that we maintain access to source code and data models so that we can always go to a legacy M&S if we want to, I think we're going to see more reuse than we've ever seen before. Some advantages of using legacy M&S are obvious, that you're going to get a leg up. Some of it's been done already. You're going to be using the experience of other developers. You've got testing and VV&A history that you can go off of. Remember, if this is done right, it's all been very well documented. You already have a credible result in another domain or a slightly different use, so adapting that to be a credible result for your use should be somewhat easier than it would be from scratch, where you have to do everything from a blank sheet of paper. But there's downsides too, so you got to remember that simulation or that model was built for a different purpose. You might have some unintended consequences or side effects you got to prepare for. This is why you need to have access to the code. There may be hardware, software that is linked to, which might be obsolete. That's becoming more rare as we move along. There may be data needs. You may find out that the previous usage was in some way inconsistent with what you're trying to do. So these are all a bunch of problems that you just want to keep your eyes on if you're using legacy M&S. But I would always prefer to go down the legacy path if I could. There's two main categories of things you really want to pay attention to when you talk about costs and the VV&A process. One is good documentation. Just do it. It might seem like a pain when you're doing it, but if you do good documentation, then when you try and use a legacy system in your program that's been well documented, you'll appreciate it just like somebody else will appreciate what you documented in your system. So documentation is number one. Number two is configuration control, source code control. We talked about GitHub or SCCS or some other mechanism for maintaining and using configuration management for your source code. So what you could actually do is you can build your source code through history. So not only does it have multiple versions through time that you can roll back, but you can even fork it. You could say, hey, here's my base source code, and I went in this direction for this use. I'm going to roll back 3 versions and fork it at this point and go and adapt it for a different use. And it's all under configuration control, and everybody benefits when you do that. This is just good practice in software engineering. And a few words on documentation philosophy. First is use the standard outline. Use standard outline. You're gonna be allowed to vary off of that somewhat, certainly, but don't make up your own thing. Lots of people do VV&A and they're expecting to see certain documents. Give them those documents in something of the form that they're expecting it in. You want to structure your results to facilitate comparison with requirements. So this is just what everybody is expecting you want to give them. This all has to do with your documentation. We've already talked about configuration management. Here is the website I promised you, msco.mil/VVA_RPGHTML, which is called the Recommended Practices Guide. Everything you're going to need is there. I highly recommend that website. MSCO keeps it up to date. So as things change, they're going to get changed on that web page. You find yourself involved with VV&A, do yourself a favor, go to that website and get the documentation, get the templates, get what you need. This is just an example. These are lists of the different sorts of documentation that you're going to find on that website, with the accreditation plan, the V&V plan, the V&V report, the accreditation report. This is everything everybody's expecting you to do. Don't wait till the end. Get it up front. Know what you're going to be doing and document it throughout. When you're done with your VV&A, you finished your program, you did your VV&A the way you're supposed to, make sure you archive these things in a central location. In a lot of cases, you don't even have to do the archiving. Your service will do it for you. If MSCO will help you, believe me, nobody is going to turn you away if you say, look, we're done with this, we want to hand it off to somebody else. so that it'll be put in a repository for somebody else to use. Nobody's going to tell you to go away. They're going to take it and they're going to index it and put it someplace where everybody can get it. So you want to make sure that whatever you do, that it can be found, that the documentation can be found, that we can perform comparisons, and we can figure out how we want to select it. Make sure that we can find it and we can use it. So wrapping up in VV&A, cost-effective accreditation requires that you have a good problem definition, a clear application description, so you know what your purpose actually is, and you don't extend past it. Explicit statements of the M&S requirements and acceptability criteria, very important. A well-planned, tailored, and focused accreditation assessment effort that goes throughout the life cycle of the software, not just something you plug into the end. Efficient V&V to support the accreditation that goes at the end requires a clearly defined application context so you can focus your efforts. The use of risk to focus and tailor the V&V effort, so you've got to know how much risk you can tolerate. A clear understanding of how each V&V activity contributes to the credibility. You've got to be asking yourself the question of what are the worst things that could happen here? How are people going to be using this thing? A means of extracting key accreditation support information from previous V&V efforts, particularly when you're talking about legacy systems, and an efficient means to produce, document, and archive everything you're doing. Because all this stuff has got to get used by other people. Otherwise, what's the point of documenting anything in the first place? This is what this is really about: is M&S folks helping other M&S folks by doing the appropriate thing, verifying, validating that what we're producing is good for a particular purpose, and then making it usable for other people. And that's VV&A in a very quick nutshell. As I said earlier, please go to that website at MISCO for more information on VV&A. The independent services all will have their own websites on VV&A as well, so you might want to look there too. But I would start with the MISCO site because it's most general to all the services. They talk to all the services. They know what all the services are doing. It's just a great place to start.